Okay, looks like it's streaming. Let me double check. Okay, we are live, guys. Awesome. No problem at all. Fantastic. Okay. This is funny because I try to watch the live stream so I can answer questions there. And it does that. Okay. Hello, everybody. I'm Sudha Jamthe, and we are live here at weeklywed from Business School of AI. I'm a technology futurist joining you from Silicon Valley. And for those of you who are here on Zoom, this is a webinar about large language models, or LLM, today. And some of you are the privileged few who are joining on the Zoom. So that means you get to ask questions. And if you do not want to be on recording, because this is streaming live onto YouTube and LinkedIn, where it will get recorded and saved. So if you don't want to be on the recording, you can go off camera. If you don't want to speak up, that's okay, then you can chat. So what I would request you is, by joining here, it's a disclaimer, you're giving us permission, because I'm going to be sharing this recording back with everybody possible. That's what I typically do. So this is a global speaker series that we have a speaker every week on Wednesdays at this time. And I'm joining from Silicon Valley, where it is bright in the morning, 8 o'clock. And it's evening in Nigeria and Europe, and night in India, where some of you have joined. So I appreciate it. And this week, and typically once in a month, we do webinars. And this is more a webinar session and not a speaker series. Okay, so I'm going to share my screen and start the webinar now. And for those of you who are on YouTube, I will not be able to come and check your questions right away, but I am also streaming on YouTube. Okay, I'm going back. As soon as I go back, it starts. I hear my own voice. I've muted. So as you can see on LinkedIn, I'm definitely going to take your questions. Oh, I see Karina and Tiffany are on LinkedIn. Good morning, Karina. Good morning, Tiffany. Thank you for joining. If you would like to be on the Zoom, I'm happy to give you the Zoom access. Otherwise, I will be coming and taking questions right from LinkedIn also. So I see some people active on LinkedIn. Okay. For those of you who are here on the Zoom, I see more people coming in. I'm not going to call on you. As I said, I will respect your privacy unless you want to speak up or you want to be on camera. So you can type your name and where you're joining us from the chat, because we are a very global community. I'm very proud of that. So I want to make sure that you connect with each other on that. Okay, so let me share my screen and I'll get started right away. Here we go. And I have a deck here and I will share the deck. And for those of you who joined on the Zoom, you must have got a notification saying that the AI assistant has been set up. So that was one reason why I was very particular that I want to do this on Zoom, because Zoom has this AI assistant capability, which is built using generative AI, exactly the language LLM model that we are talking about. And so this conversation, not the chat, we just started testing this from last week. So I figured out it's not the chat, it's the transcript of this session. So any questions, any discussions that is coming up here, everything that I'm speaking and presenting, all that is going to be transcribed and summarized. So everybody who is signed up on the Zoom will get a copy of the summary sent by the AI. And I thought it was pretty decent, barring a couple mistakes last time. So that too, it was more like a question when there was a conversation. It kind of mixed up people and name. Otherwise, it had follow-ups and to-dos and everything else. So if I promise that I'm going to send you the deck, if I promise you anything else, it's going to hold me accountable because it's going to put my name in the next steps of the summary. Okay. So now let me share my screen and go to the entire screen would be better, I think. Okay, it's showing myself here and here. Are you guys able to see my screen? No, you're able to see. Are you able to see my window with the deck? Nope. Okay, I'll just share a tab then, it's fine. I'm going to try to share audio, share a tab or screen. Okay. Gonna try one more time, guys. Okay. Here we go. Okay. I believe this should be sharing my screen right now. Okay. Are you guys able to see my deck?
Yes, can see it.
Yes. Thank you, Yash. And I want to actually share the window where the live stream is happening so that you can watch for comments. Somebody, if you volunteer to look for comments, I'll appreciate that. So I'm going to put that in the chat here. Let me stop this because I cannot see the chat while I'm. Okay, 1 second. Okay. Okay. If somebody, I just shared here in the chat. Yes. Thank you, Stephen. I just shared in the chat. So if somebody monitors that and brings the questions here, I'll appreciate that. Otherwise, and when it makes logical sense, I will switch back to see that. Okay. So I'm going to go back to share. So we're going to talk about large language models. Okay. I already did an intro, so I'm going to skip that. And for those of you who are joining on live stream especially and coming back or watching the live stream later, so this is part of our weeklywed global speaker series, and today is the webinar on large language models. And we usually do this for an hour. I'm going to try and keep it on time. Okay, so my name is Sudha Jamthe. J in my name is not silent. I'm a technology futurist and AI researcher, and you can connect with me on all social channels, especially on LinkedIn at Sudha Jamthe. And especially since we are talking about generative AI, if and LLM, if that topic is of interest to you, you can sign up on my website because I have separate follow-ups I send just on generative AI. Okay, so I'm going to skip my intro, but I bring a mix of technology and academics and write books. But for today, we're just going to focus on LLM. Okay, so what can you expect in this webinar? I will promise to keep it interactive, so you have to help me to keep it interactive. Otherwise, I will be doing the talking. So my aspiration here is I will give you a foundation on what are LLMs, and I want to delve deeper into how they work. My motivation to bring this webinar is I see a lot of sessions happening about LLMs and focused on various different technologies and people building list. And here I'm here in a pure knowledge sharing as part of our weekly Wednesday that we've been doing for many years. And I hope that we will build up on what we've been learning in the past, and you will have free access to this recording and you can go back. But I want you to walk away with confidence. I do not want you to think that this is limited to any particular technology or a specific brand or company, because I don't have any specific affiliation to any company. I will agnostically tell you about everything that I know of. And if you ask me questions, if I don't have the answers, there are other experts in the room I might call on, or I might go back and find the answer for you. And one of the things that is my specialty is I teach AI using no-code AI. So I'm very big on making sure that we go deeper into the technology, into the models, and that you have complete confidence on jargons and don't feel intimidated either during the session or afterwards. So we're going to go deeper into how the actual LLM works. And then I'm going to go to the application. My aspiration is that we will spend a lot of time on this actual application and sequencing and how you do that, because that is what I want you to get to as the next step, so you can actually build real LLMs. Okay, so I'm going to stop the share for a second. Just give me 1 minute, guys. Okay, I'm sorry, my dog wanted to just come in. I actually call her a machine learning dog because she would not change her behavior on how I do. Okay, so I'm back, guys. Sorry about that. So no more disturbance now, and I should be able to continue on with our thing. Okay, so I have a question for you, for people who are here. We have done a session on foundation models before the whole ChatGPT thing picked up, and it was like a big deal last November. I think we did this when the foundation model concept or the term was introduced by Stanford, and there was controversy on should they call it foundation model or not, and stuff like that. So maybe, I would say more than a year's time back is my gut. And that recording is here at weeklywed. If you want to go back, look at it. We had this discussion on foundation models, what they are. So my question to you is an LLM or a large language model a foundation model? Yes or no? And if you're building foundation models, I would ask you to, be a little bit respectful of the others who are new. But this is a basic question. So, and thank you, Bernard. I see you're here from Ghana, so that's wonderful. We always welcome new people. So I'm a big fan of Masakane. So I don't know if you came from Masakane, then, I might call on you for answers then. Okay, so is foundation model, is LLM a foundation model? Yes or no? What's everybody saying in the chat here? Oh, I see someone from Brazil also. Wonderful. We have a good international mix here. Okay, is LLM a foundation model? Yes or no question. Just type your answer, guys. Okay, so I'm going to go back to see whether anybody is saying that in the LinkedIn chat. Okay. Is the foundation model, is LLM and foundation model one and the same? Are they different? Okay. So I'm going to go back to share my screen again because people need a little boot up time. I don't want to put you on the spot. As I promised, if you talk to me more, you're going to make it more interactive. I'm going to come back to this slide because we have several different newsletters and people ask me what is what. So Pariya has put together a slide listing all the various newsletters here on prompt engineering and registration for weeklywed and generative AI newsletter too. Okay, so foundation model is something that is built using large volume of data and it is bigger than just LLMs. LLMs is focused just on text-based foundation models. So yes, an LLM is a foundation model, but foundational models are bigger than just LLM. That's my answer. Okay, so I went through that. So what is a LLM, or a large language model? It's essentially a neural network, and it is based on a specific kind of model called transformer model, which I'm going to explain in a minute. And it is trained on a large set of data or words, and it is focused on prediction of words, right? So that's the whole idea, that the excitement with ChatGPT is an application that is built on top of GPT 3.5, which is a foundation model or a large language model. So the one thing that people usually jump at is an LLM, a neural network, and the answer is yes. But it is made of a different kind of model called a transformer model. Okay, so I always like to do a demo and talk to real models, because they're all around us. AI is so pervasive that these days you just don't have to kind of theoretically talk about it, or just go build code on Python or something. It's everywhere, so we can chat with one. So there is a LLM called BERT, and I'm going to talk to that one. And Google search is an example of that. So I'm going to come back, share my window back. Okay. Okay. Let me go there. Back again. And I have to do this at one Chrome tab at a time, because I'm on a Chrome book these days, testing it out. Okay, so I'm on Google. What should I say? I'm going to say and it tries to fill up the next word. It's guessing the next word. I am doing what? Doing well, doing a new thing, doing well in French. I don't know French at all. I'm doing great. I am doing a new thing. A demo lesson, demon. Ooh. And demotivated. So it fills up the same word. It doesn't have to be the next word. So this is great that it showed me that, because I was trying to show you, usually people say that LLMs are guessing the next word. And I would be using that phrase also as we are talking today. But the reality is it could be the same word. It's just trying to guess tokens. Tokens could be just pieces of word. That's the way the model is trained underneath. So it is, I'm doing a demo of LLM model in a sentence in a webinar. So you get the idea, right? So I'm going to stop that. So what is that? What I showed you is Google actually showing me that it is using a search. It is using a LLM model to guess the next best word. So that is called BERT, or bidirectional encoder representations from transformer. And you can see right here at the bottom, I've actually added the citation of this particular paper. And this was, I believe, in 2019. And this set off, at that point, there was no GPT or anything else. And this set off a whole set of innovations that brought us to where we are with GPT launching ChatGPT, the application. So that kind of, got the world excited about these transformer models. So the lesson here is that And I believe Google has updated. They might not be using BERT. They might be using Lambda or Palm, one of their newer models these days in the search. But the concept is they started out with BERT, which was doing the same thing, right? So it was trying to guess the next word and not just the word. It was trying to finish up the word. It was trying to finish up my next sentence, but not the full sentence. So it shows the full sentence. It's just trying to finish up the next token or piece of word by which it has been trained. And we'll talk about what are tokens in a minute. So how does an LLM work? So the LLM is based on transformer, which I'm going to show you a video which will do a better explanation than what I can tell you. So we'll about how the transformer model, but it's basically built using a transformer model. So what the AI does is, so all AI is trained using data. So LLM is trained using data, which is words. And all the LLMs that's out there are trained using the entire volume of data out in the internet, Reddit forums, all kinds of this, everything that they could scrape off the internet as words and some books, saying, okay, we've got the whole world. They haven't got the whole world, but they've got publicly available versions of English language in with um, all the open whatever is out in the open, good and bad, with a lot of biases and stuff like that. But it creates a huge volume of data, right? So they took that data and built a large model. That's how foundation models were built. And with words, that became the language model, because the model is essentially trying to talk to us, like we saw in the search demo I showed you. It's trying to finish up my sentence and guess what I'm saying, and finish up the sentence. And that's how it has a conversation. But getting this model to do a conversation is a totally different exercise. And we are going to get to how we'll make that happen. And chat is just one of the applications of LLMs. Can you think of other applications of LLM? What kind of other things can an LLM do before I get to this? How it gets to work. So can somebody tell me what kind of other things can LLMs do? And especially in the chat, you are a privileged group. You get to, yes, so you said yes. Okay, you get to answer my question and tell me what other things can LLMs do. So there's large language models. I gave you one example of BERT, which got us into something called image GPT, and then it became GPT, GPT-2, 3, 3.5. At 3.5, they built the application called ChatGPT, and then OpenAI, which came up with GPT, has continued on and has built GPT 4.0, which is multimodal, which means it is not just limited to words, it's words and images and sound and code, and it can generate all kinds of things in one place. And that's where we are going, right? And then Google, who started this whole thing with the paper call attention is all we need, and introduced the transfer model, said, hey, but we started it. And so they continued on and said, here is our version of equivalent of GPT, and they don't like it being called equivalent of GPT because it's their own model, called Bard. And Bard is generally available, so we can play with that too if you want to try that out. Okay. So question. So let's see what the answers are. So it can create. Okay. So I was asking what other things can it do, and idea generation. Who said idea generation? Yes, I thought that must be Suresh, because Suresh is
Yeah,
full
hey
of
Sudha,
creative
that was
ideas.
me.
Yes. Okay. So here's a language model, large language model, LLM, and you can build it out to do things. So one of them is can generate new ideas. That's a very fantastic suggestion of what it can do, because the idea of LLMs is it's generating content, right? It is generating new things, so it can generate ideas. And I'm going to come back to that. I didn't have a conversation with Suresh ahead of time, so it is genuinely what he came with of what that would be. um, Idea generation, create tables and graphs from data. Yeah, uh, that is one. In fact, we are going to have a live demo of a recommender system being built live using ChatGPT by somebody who's an expert on recommender systems. So you'll have to wait for that. Okay, so what are the things? I told you that we are going to have generative AI, that is created this AI assistant on Zoom to summarize this meeting. So summarization is the most common text summarization. So there are a lot of tools out there where you can feed a document and it will generate a summary of that of the text. So that is one that is very, very common that we are seeing these days. And then it is, ChatGPT is what brought us to, brought generative AI to this place. And so having a chat is one, and the chat could be many things, right? Is it giving a suggestion in a chat? Is it doing Q&A in a chat? It could be there is more. So think about this. We've learned about how AI is trained with data in the past. When we were talking about machine learning and deep learning, we gave huge volume of data, we got a model, and then we said, okay, now let's test out the model. Is the model making the decision the way we want it? And we've done courses on self-driving cars. We've done on building recommender systems. We built general machine learning models. Or Sam Wigglesworth had done a NLP course here, right here, and that was using NLP before the large language models and foundation models were created, right? And so all of that was about taking data. Magically, somehow, a model was built, statistical model was built, and then the AI was ready, and we said, okay, is the AI ready for inference, which is now it's ready for production, let's test it out. At that point, we tested it out, and then we retrained it back many times till it got to a level of performance, and we were like, okay, now it's ready, it's recommending things, it is making decisions, it's making predictions. At every point, the AI is making predictions the way we want, to a level of confidence without much mistakes. And that's exactly what the LLM models are going to do. It's going to make a prediction. It's trained with data. It's just a different kind of model. It's not the typical machine learning model. It's a transformer-based model. But now when you have the model, then the application layer you build is what we are talking about. So it can do text summarization. So this AI assistant that Zoom has created has been built using a generative AI model. And we've seen some example, and some of you have seen me chat with Akio to have a conversation with data. Who said that? Talking to data. Okay, so if you want to see a demo of that, I might show that at a later time about how to create tables and graphs from data, because I'm going to keep the demo to the recommender system that I want to go back to. Okay, so let's continue on. And thank you for your answers. Okay, so I was in the slide saying how the LLM works. So it's built using transformer model. I've said that 10 times already, so I'm going to come tell you that in a minute. But what it does is the AI, because this is language, right? Huge volume of data has been fed, and the AI is creating a mental map of the words and their relationship to each other. And this is done using not just, that this word comes next to this word. So I told you about BERT, and BERT is bidirectional, which means it is looking at the training data and when it was trained, and it is going to look at what word came before a certain word, what came after that word. So it looks at both sides. And GPT does it in a single direction. We, in English language, we read from left to right. There are other languages you read the other way around, or you go top to bottom. But in English, it is read from left to right. So GPT does only a single direction. So when you put a word, it just tries to guess the next word. And so the training data, when it was fed the world of data from the internet, what it does is it took all the words and create a mental map. And it said, okay, how is each word related to every other word? And based on how often a word is used is how it created a mental map. and that is what it you has in its training. So what is the difference between the past machine learning and other deep learning that we knew as models and generative AI models and LLM specifically? Let's focus on LLMs, but I'm loosely using the word generative AI because this is a broader concept. What I'm telling you is machine learning or deep learning, image classification, regression, all the things that we learned in the past, and generative AI is there's one big difference. What is the difference? You can chat your answer. You can speak up if you want. If you're here, I'm fine with that. What is how is fundamentally what one there is one fundamental difference. It's trained by data. It creates a model. It generates an inference and it makes a prediction. These are all common. That's how AI operates, right? Yes, it is trained using a huge volume of data. So that's why it's called large language models. And it's called foundation models because the thinking was it's going to create the foundation of building the rest of the AI that we've been waiting for. Okay. So what is different with generative AI models compared to machine learning or deep learning as we knew in the past? What's one critical difference? It's trained by data, it creates a model, it runs inference that makes a prediction. When you say, can this self-driving car go move? Yes, forward, yes or no? Or when you're chatting and you're asking a question, it gives you an answer. It guesses the next word. Or if you're running data and you're saying, okay, I want a weather prediction, and there's like a health prediction. Everything is a prediction, right? This is also making a prediction, but what is it doing? Different. I want to go to the LinkedIn and see if I'm getting any answers. So for those of you who are on LinkedIn, you could tell me too, what is the difference? What is it doing? When you're generating using a generative AI, what is it doing? So the main difference is in a generative AI model, it is generating, which means it is creating, right? Yeah, brain like memory. So you could say every neural network, thank you for that, Yash. You could say every neural network is trying to act like the brain, right? So it has multiple layers and it has neurons and there is memory. But with and I'm very happy Yash is here. I was just looking for a basic answer that a generative AI is going to generate content. A typical machine learning model would look back in its training, and when it makes a prediction, it is going to fetch that answer from its training data. And if you're even chatting, it's going to bring something that's already in its memory, right? In its training memory. Whereas generative AI is going to use that as knowledge and it's going to generate the content. So what it is giving out as a prediction, as a chat, in image generators, where if it's generating an image or a code, it is not bringing something from its memory. It is generating based on that knowledge. So that's the fundamental difference, that it is not, even when you have a chat and a conversation, each word, each sentence is new. It's not something that was already in its memory and it's just fetching. It is going back to its memory. Remember, the LLM is basically, when it is trained, it created a mental map of what are these words, what are these relations of these words with each other, and it created a mental map, and based on that it goes back and guesses the next word. So it knows which word is more important, which, when we are talking, what would be the next probable word that it should be saying. Like I was showing you in the Google search example, it's going to do that, but it is generating it. It's not just fetching a sentence that's already in its memory. Okay, so I'm going to go back. Okay, so why is it called a large language model? Why is the LLM called a large language model? What is the large about it? Any takers? Because I know this looks very basic, but when you hear people throwing a lot of jargons and explaining things, I do not want you to ever have any doubt and second guess yourself, because once you get out of this webinar, every jargon is going to demystify. You're going to have a very solid foundation of how this works in its brain. It doesn't matter if you code or not. Yes. So it has large volume of data. That's one. So the most common answer people think is it's large volume of data. And for those of you who have taken my class before, what are the 4 V's of data? So when in training data, when we're looking at training data, the 4 V's of data is volume of data, veracity of data, velocity of data. There's a fourth one. What am I missing? Variety of data. So in this case, the focus has been on large. It has not been on the veracity. Veracity is like, okay, the data is clean and trustworthy. We know the data lineage of where is the starting point of this data. So typically, if you're looking at marketing data in a company and building a machine learning model, and there's a model similar to this next best word that the LLMs guess in marketing, there is a model called next best click. And we had a speaker come in, one of my students who's an exec, come in and do a demo of that, the next best click, where the customer is going to click based on training data. So that is in that case, they would look at the veracity of data. They will not make guesses and run a business and go invest money. But the large language models don't care about the veracity. They've just scraped things from the internet. It's full of biases. So because of that, the large has been focused on volume. That's primarily. It's not live. Velocity would be that the data is a streaming data. In this case, it's not streaming data. It's not credible data from where it is built. So there's no veracity of the data. What am I missing? Variety of data. Variety of data is, it could be different sources. It could be different kinds of data. And when they are building models that has, multimodal, as in voice and text and image and everything in the same model, you could say it's variety. But right now, the large language models are just focused on volume. So that is one. What's the other thing? So yes, just given the answer for that. So it's the architecture itself. So the way, first of all, the language models are neural networks. So they have multiple layers in their brain, right? So there's an input, and then it goes through multiple layers, and then it produces an output. So we just see that it is guessing the next word. It's continuing to have an amazing conversation and a chat with us. How does it do that? It does that because in its architecture, there are these parameters. So in normal machine learning, there is this concept of weights and biases. Okay, I'm going to go back to my tab so you can see this back again. Okay, so in a normal machine learning model, you have something called weights and biases. So there's an input layer for a neural network, and the large language model is a neural network. And some of you might have taken classes and they would say, is that a neural network? Yes or no? And you might say, no, the neural network is something from the past. It's not. And I'm going to tie this back to what we have learned as machine learning and deep learning, right? So the large language model is a neural network, and they took large volume of data as words from the internet and created a neural network. It's just a different kind of neural network transformer, right? So, but it has many layers in there. So what you see is input, one word, and then you see the output. Or you're chatting and it gives you the output, right? So weights is, how does it know which word is important? So the way the neural network learns, I'm still thinking about training. So don't think about ChatGPT when you're chatting with ChatGPT. That's running inference. It's chatting with you as a customer. The model has been built. What we are trying to do is go into the brains of the LLM to see how does it work. How does this build this knowledge so that it can generate the content, it can generate code, it can generate images, it can generate all kinds of things, right? So in this case, for it to chat, for it to do text summarization, For it to do language translation, that is another common application, machine translation of one language to another language. So the input could be a sentence that I'm speaking in English. The output could be the sentence translated into Spanish. So it is not just giving the translation of a word, it is doing the translation of the sentence. So in that case, it is not just doing word by word, it's guessing words, but it understands the context of the language. It's bidirectional for translation typically. So for all of them, the training is where the foundation model or the LLM was built. We are digging deeper to see how does that work, what did they do in the training, and how can the next step of it is, now that the model is available, what can we do with it, how can we build with it, right? So the important thing here is there is knowledge that is captured in each layer, and then it is passed on or propagated forward to the next layer till you get to the output, where you just get the output, you don't see all the different things that happened in the middle. So what knowledge of that word, which word is important in each layer, right? Because finally you get one answer. So of all the possible words in its mental map, which word is important is the weights. So these weights and biases are adjusted numbers provided during the training or the pre-training itself. And we don't get to see it. We are just talking about it to understand the basics of it. We are not going to play with it to give the weights and biases. Okay. So the weights is how what word is important, that it comes out. When I'm chatting and it says, what am I doing, right? It gives next word, it just gives the output, but it propagates that word through the whole network. Which word is important? How does it know which word is important in each layer? That's the weights. And then how does it know that what learning should it propagate into the next layer? How does it know, how it decides what one word versus another word, what is the relationship map of those words? That is the bias. So either the weights or the biases is called a parameter. So you would see, this is a screen grab I got from my book, The Generative AI, a primer for product and business managers, where I explain all the models. This is just a table showing the number of parameters. So you see these words, oh, but that GPT-4 is 175 trillion parameters, and GPT-3 is 175 billion parameter. And, we see all this. This NLLB is a large language model from Meta. Bert was the one I was starting this whole conversation today, and Lambda and Palm are the ones from Google, and there's many, many more. But still, it's a small number because it takes a lot of GPU cycle to actually build out these foundation models. Because if it is that many parameters, then it's that many amount of processing it is doing in each of these layers. And the unfortunate truth is, the bigger the number of parameters, does it matter? To some extent it does, because the more parameters it has, then it understands the relationship of each word to other words in a much more intricate way. And so the accuracy of the model can be better. So it's a factor that contributes. So more and more models are launched with more um, parameters. The unfortunate truth is, it takes a lot of GPU power, which means it costs a lot of energy to run these processes to build out these models. So hopefully we won't continue on building just huge, humongous models, just doing that. Okay, so now I want to get to the crux of this. So when the LLM, when it looks at words, it's not just words. They could have taken every word in the dictionary and then mapped it to a number, because the computers, the models understand only numbers. So they don't understand words. Doesn't matter what language it is. It looks like it's in English. It doesn't matter. So it takes, what they do is they have, when they train, we are still talking about training, how they build this, right? They fed data and they fed words, but they fed chunks of words called tokens. And so when you try to go to use GPT on Playground, this whole concept of tokenization comes in, because they'll say, how many tokens are you going to use? We'll give you so many free tokens. When that expires, then you need to pay for more tokens. And this is what you're paying for on a monthly basis, this many tokens. So that, and the tokens in training is what they did that I'm talking about. What they will charge you is tokens in inference, where you will be running the model and it's going to spit out words, and it's going to be made of so many tokens, and they'll charge you for it. So the token is a very, very important word to remember in all the jargons of today. So this concept of tokenization is when you're trying to build a training model, you have to take a large language diaspora. You have to take a large language content, and you have to build it into tokens. And so there's a lot of tools and exercise on how do you actually take words and make them into tokens, because that's what it understands. And the way the model works is it takes the words and associates a number with it. And it's not just one number, it's a vector, it's a series of numbers. That concept is how it does it. The vectorization, how it takes the words and makes it into a number, is called word embeddings. That is the basis of this whole transformer model that I'm talking. So previously, when we were doing machine learning, we had a bunch of words, we fed that, we had a bunch of numbers, we fed that as training, it didn't matter. So now it is trying to understand, where should I focus my attention on, which word is more important, because it is giving a very accurate conversation when it is talking to us. So the vectors is just a set of numbers, and that represents the words. It could represent a sequence of words, it represents the sentences. The picture here is an attempt to show that the similar sounding words are grouped together because of this concept of attention. That is how the transformer model is built. So what I'm going to do is, instead of explaining this, there is a paper called Attention is, wait a minute, I'm going to stop this. And I think I have that video set up for you. So I'm just going to show you, because this is a much better explanation of this, and it'll be faster, because I want to give Yash time to show us a beautiful demo that she's waiting to build out a recommender system. Okay, so what we spoke about is, we talked about words tokenized, and we spoke about, I believe this is the only window. Let me check. I don't want to go to another YouTube window. Okay, yes. Okay, somebody please confirm you're able to hear the sound as soon as I start, guys, okay? You can speak up, that's faster. So the concept is, we learned about how the training happens. We're still in the training, in the brain of the LLM, how it works is all that we have been focusing on, right? We have not taken the training, we've not taken the LLM, trained it to build anything else. That's the next step, right? We are looking at how the LLM is built. What's the big deal? Why is it different from machine learning and deep learning, what we have learned in the past? So it's based on a transformer model, and all the words are broken into tokens, and the words are mapped into a number, because the computer understands only numbers. And how it builds the number such that it knows which word is more important and the next one, so that it can propagate the right word through the neural network, so that it can make the next right guess while the AI is chatting with us, is the important thing. So
this power was demonstrated in the paper Attention is All You Need, where the authors introduce a new novel neural network.
So you guys are able to hear, I believe?
Yes, we can hear it just fine.
Sudha.
Yes, thank you, guys. Okay. So attention is all you need. It just changed the world and created transformer model from where everything that we are talking about in generative AI on the language side has evolved.
Network called the Transformers, which is an attention-based encoder-decoder type architecture. On a high level, the encoder maps an input sequence into an abstract continuous representation that holds all the learned information of that input. The decoder then takes that continuous representation and step by step generates a single output while also being fed the previous outputs. Let's walk through an example. The attention is all you need paper applied to transformer model on a neural machine translation problem. Our demonstration of the transformer model would be a conversational chatbot. The example would take in an input text, "Hi, how are you?" and generate the response, "I am fine." Let's break down the mechanics of the network step by step. The first step is feeding our input into a word embedding layer. A word embedding layer can be thought of as a lookup table to grab a learned vector representation of each word. Neural networks learn through numbers, so each word maps to a vector with continuous values to represent that word. Next step is to inject positional information into the embeddings. Because a transformer encoder has no recurrence like recurrent neural networks, we must add information about the positions into the input embeddings. This is done using positional encoding. The authors came up with a clever trick using sine and cosine functions. We won't go into the mathematical details of the positional encodings in this video, but here are the basics. For every odd time step, create a vector using the cosine function. For every even time step, create a vector using the sine function. Then add those vectors to their corresponding embedding vector. This successfully gives the network information on the positions of each vector. The sine and cosine functions were chosen in tandem because they have linear properties the model can easily learn to attend to. Now we have the encoder layer. The encoder layer's job is to map all input sequence into an abstract continuous representation that holds the learned information for that entire sequence. It contains two submodules, multi-headed attention followed by a fully connected network. There are also residual connections around each of the two submodules, followed by a layer normalization. To break this down, let's look at the multi-headed attention module. Multi-headed attention in the encoder applies a specific attention mechanism called self-attention. Self-attention allows the model to associate each individual word in the input to other words in the input. So in our example, it's possible that our model can learn to associate the word you with how and are. It's also possible that the model learns that words structured in this pattern are typically a question, so respond appropriately. To achieve self-attention, we feed the input into three distinct fully connected layers to create the query, key, and value vectors. What are these vectors exactly? I found a good explanation on Stack Exchange stating,
Okay,
the
I'm going to
query
pause here. I wanted you to understand that how there is a concept of encoder, and then it abstracts and brings it out into a decoder. And this whole concept is self-attention. Every word in the sentence it counts. So when you feed a training data, it counts how many times that word is used. So if you have a whole training data, which is they fed the internet, suppose you're taking a whole document and imagine you're building this training data. It will take each word and have how many times that word is used, and then it maps how many times each word is associated with every other word into a vector. So that knowledge is what it is collecting. So it is important what goes into your training data. If your training data is using certain words a lot, and not using certain words, some rare words, if it is not using, then finally when the model has learned and then it is trying to generate its the next word while it is chatting, it will never use the rare word because it's rare, right? It thinks that word is not important because that word is not used. So the word like a and the and all of those are going to be there in excess also, right? So that is very important for you to know, especially if you're a linguist and you're saying, I'm going to take a data, I'm going to create this for a new language, I'm going to take an existing model, and there's a concept of fine tuning. What we've been discussing today is we take the model and we've understood, or we're trying to understand, how is the training done? What is the brains of the LLM? How does it work? The next step is, once the LLM is given to you, how do you use that and how do you do the next level of supervised learning on top of this neural network so that you can make it do something, make the chat talk on certain things or build out certain things. So that's the second part of it. We haven't gotten to that. If there is enough interest, I would do a part 2 of this webinar and we can go deeper into that. But I want you to understand the foundation piece, because if you are going to get any kind of training data, it is important to understand how it runs in the brain of the model. Okay, so I'm going to skip past the transformer. I believe this is being shared. Yes. So the GPT, I already told you, the GPT is a single directional, so it's encoder. It's a single direction, so it's doing only decoder. And then we talked about a lot, right, of different applications, right? How you train a chatbot is the next step that I'm going to go towards, but we are not there right now from the foundation we've set. I want to pause and show you a real example of what you're seeing, right? Of how you can use this. So what I'm going to do is I'm going to stop the share, come back, and give my control to Yash. Yashashwini Vishwanath, are you here?
Yes,
Yes.
I'm excited about the demo.
Yes. So all we've learned is to dig deeper to see how does it work, in how they have built the inference, how they've built the training to get us to these large language models. Large is lot of data, lot of parameters. The parameters are weights and biases, and it costs a lot of GPU power and time and money. So not everybody has foundation models. That's why we have limited options. But the core of it is there is this concept of self-attention and how the model understands what is more important. So this is where I'm going to park, because the next step of this is, and I told you what is, I just showed you GPT and BERT, right? And Lambda and Palm are all similar ones. And I have the explanation of it, especially if you don't have my book, or, it's not available in your region, or it doesn't matter. I'm happy to give you a chapter which explains all the different models. So there's no point in just going more and more into just explaining more models. Now I want you to see, okay, this is how it's built. Self-attention, it has encoder, it has decoder, it has all in its brain, and it's generating content. It's not just pulling it from training. That's what we got today, right? So far, we've arrived at that. How do you put it to use? How do you build the summarization? How do you build the Q&A? How do you build the chat GPT, right? So that's the next step of it. And there's a whole concept of sequence and different kind of methods of building NLP, not even application level, different kind of NLP domains, it's called, the summarization, the Q&A, what you can do. And we'll get to that. And I'm happy to do the next version of this webinar if that's of interest to you. But I'm going to give it to Yash, because she is going to show us how you can talk to an existing chatbot, the famous one, ChatGPT, and build a recommender system. Yash, do you want to take it away?
Yes.
I think I've given you access to be a host so you can share. And Yash is going to do this live. Yash is an AI researcher, a brilliant AI researcher who knows recommender systems like nobody else that I know of. Yes, Yash, the floor is yours.
Yeah, thank you. Thank you, Sudha, and thanks for the wonderful opportunity. So I'm all excited about the demo. What we need for this demo is we need a Jupyter notebook. I will quickly share my screen, which has an open Jupyter notebook. So we have a Jupyter notebook ready here, and we have, first of all, we need to have OpenAI. For that, we need to do a pip install. So here is the code for installing OpenAI. So first I do that. So I pip install OpenAI. So Jupyter Notebook is an editor where you run your code, connect to the TPUs, connect to the GPUs, and that's how you run your code. So OpenAI is already installed here. So the next one is I'm going to import OpenAI. I'm going to import OpenAI. I'm showing it cell by cell so that you'll be able to work with it when you go back to your place. And there is an OpenAI key here. This is a secret key, which we generally generate. And it's specific to what we do. And these keys are generated when we have an account, and it is specific to what we do. Here is the code that gets a completion of the prompt. So I want to explain this code. The function, this is Python. This language is Python, and it is very easy to understand. I would like to explain what is this code doing. It's really fun to know that. The get completion function, it takes a prompt and takes the model GPT 3.5 Turbo, and it takes the messages, what are the different parts it takes, and it gives a response by calling the OpenAI API. So how do we access ChatGPT? We can use it using the playground, or we can use code like this from a Jupyter notebook. There is temperature here. If we see here, there's a temperature. This is very good, what to know about temperature. It's the degree of randomness of the model's output. Then whatever response we get from ChatGPT, we save it and we return it. So this is a code that actually interacts with ChatGPT. Next, I would like to...
Yes, I'm sorry to interrupt. So I just want to make sure that we have people understand the concept of temperature, because you said it's the degree of randomness. So I've heard that temperature is of the model is how creative can it get, because the model is going to generate. So you can have a very safe temperature where you know that the model is going to generate without too much randomness, or you can have a high temperature where it is very creative and it can go and into areas in its learning that is kind of risky. Is that accurate way of describing temperature?
Yes. And we have the privilege to change it based on the application that we are trying to build and how much creativity we want in that. It is our choice. We can have 0, 0.5, 1. It's up to us. So here I have given temperature 0. So it does only based on whatever training data it has got. So here what I will do is I will put a movie I have seen. I'll put the movie Frozen. And the coolest thing about this is I will try to build a recommender out of this ChatGPT. If you see here, I give it a prompt. Provide similar movies to the movie, okay, to the input that I have given. And I ask for the completion. So now this code, this Jupyter notebook is asking ChatGPT to provide similar movies to the movie. So in recommender systems, we have content-based recommender systems, we have collaborative recommender systems. Content-based recommender system, it uses the features of the to give the recommendation. In collaborative, it uses the reviews and the ratings. So this is content-based recommender system. And now when I print the recommendation that it has given, we see similar movies such as Tangled. It has given an explanation. See, that's the beauty of it. It has given an explanation as to why it was recommended. We have given Frozen as the initial movie. It has given Tangled. It's another Disney film. with strong female protagonist and magical adventure. Moana, Brave, The Little Mermaid. So it has given all Disney films and Pixar films, which are animated movies. So this is content-based recommender systems where we are using the features of the movie that we are trying here. Next, what I would like to show is serendipity. Serendipity is if you go to your Netflix, there is a special button which says surprise us. So that is serendipity. Serendipity is surprising you, provide movies which are dissimilar from the movie, and tell it why it was selected. So this is again content-based, but serendipitous recommendations. So as we wait for, so here if you see, it is taking some time to get the response. And this is very crucial when we are building real-time systems. What is the time taken to get the response? So here we have the movie Frozen and The Dark Knight, The Godfather, The Inception, Pulp Fiction. All these are dissimilar. It's telling Dark Knight is dark and gritty action movie centered around Batman. So this is serendipity, serendipitous recommendations. Next, what I would like to show is collaborative filtering. How ChatGPT can do collaborative filtering. In collaborative filtering, it takes from the users the ratings and the reviews, and it provides similar movies. So we have IMDb, which is the movie database. And here we get, this is the response that we have got. And whatever is the rating similar to Frozen, here we are getting similar movies based on the ratings. So this is collaborative filtering. Now we see that ChatGPT is able to do both content-based filtering and collaborative filtering. But what I want to truly show today is how biased it is. It is a little off topic from today's discussion, but I cannot go without showing this. This is showing how biased ChatGPT is, and I really want to show this.
It's not off topic because I want people to understand how training is done. Even for temperature, I was trying to show there are certain things that comes with the training that you cannot touch, right? Because it's in the brain of what data they used to train, what parameters they used, what were where the weights and biases they use. We can't touch it. It's not transparent, right? But
Yes.
we can, when we build the application based on LLM, we have more control over it. But still we are stuck with what is in the training data, right? If it is stolen data, if it is biased data, it's going to generate based on that. So thank you for making sure that we understand this, not just get excited. Yes, it can build recommender system. So back to you, Yash.
Thanks, Sudha. And here when we run this, we are acquiring ChatGPT, provide movies for girls to watch. So let's wait and watch what movies it recommends for us. So these are the movies that it is recommending. The Mean Girls, The Princess Diaries, Legally Blonde, Clueless, Pitch Perfect, The Devil Wears Prada, Frozen, Moana, Little Woman. So here we see that there is a bias that ChatGPT already comes with. The bias that we see, the gender bias that we see outside in the society, ChatGPT comes with it within. And this is an alarm signal for us to know that these large language models come with biases which are there out in the real world. So Sudha, can you add your thoughts on this?
Definitely. Thank you so much, because I did say that we don't have any control over what data it is trained on, and it just scraped internet content. So when they say it's trained by the world, it's not the world, right? Yes, the world has biases, but there are good people without the bias too. It did not collect training data from anybody else. It scraped from Reddit forums. It scraped from, they collected data like that from the internet, which is known to be having, all kinds of isms, right? So here is a racist, or in this case it is sexist, and it's collected that data, so it's obviously going to bring that gender bias. So if we start thinking that AI is going to build the world, and here we are talking to chat gpt, and we are going to build other chatbots, we are going to build all kinds of other applications on top of it, then it is pretty alarming that we are going to use data that is very biased. And you were smart enough to prompt and find out, so you have to prompt and get to find out that, right, we had Robert Schwenkter come and do a prompt engineering session a while back, and we have it available as a webinar, even as a certificate course, if somebody wants to just spend an hour and get prompt engineering certificate, because prompting is how you get into the brain of the AI. So at least we have that possibility. But there is a concept called prompt tuning. I don't know if I can mention that here at this time. Yash, I don't want to deviate from where you're going with your thoughts.
Yes.
So the common thing that people will hear about is you take the LLM that is given to you. In this case, Yash is using Playground from OpenAI, which is GPT, right? Or you may take another one from an open source model. You find one of the foundation models that's available out there, and you build on top of it, because you cannot go build that number of parameters and build a foundation model from scratch. So what's available to us is, whenever we want to build an application, a text summarization, a chatbot, or make the ChatGPT do all these amazing things like build the recommender systems, and there's a lot more possibility. So I'm very glad Yash came in to not just say, we were talking about what examples, what can it do? It can do text summarization, it can do Q&A, it can do machine translation, and we can build chats, right? That's where we were going with it. And then you came in and say, here's an application that's been built. Now I'm going to prompt it and make it do something else for me. That's the direction people are going. The other thing is, in enterprise, people are saying, here is one of the foundation models that's available. I'm going to fine tune it, which means you live with what is given to you, which is this biased model as a foundation. And then you take a small, narrow data set that is yours. So you want to build a chatbot. That is going to provide customer support for a travel agency or something very specific to your business, and you fine tune that. So there's a concept of fine tuning. So people were thinking till recently that it's biased, and I have to prompt to find out what is the bias, and it might insult my business, put my business at risk, or say something unethical, and when it is interacting with my customers. And there is a new concept called prompt tuning. So the only access you have into the brains of the LLM or any foundation model is by prompting. And so people were doing malicious things like prompt injection to make it forget its training and try to do different things, like different kind of prompts. But this whole prompt tuning concept is that you can take a small data set and make it go away from its bias to become unbiased. So I'm going to share what is prompt tuning in the prompt engineering newsletter. But because we are out of time, I just want to wrap this up. Today, we've just learned foundation model. Yes, LLM is a foundation model. Large data, large parameters. Parameters are weights and biases based on transformer model with encoder, decoder, and self-attention. We just looked at BERT and GPT. There's many more models, but it's a finite set of models. And then in its brain, it's basically how it is trained is using words. So you could train by taking taking a set of data and making it into tokens, and then it does word embeddings or vectorization. And that's how it has the smartness to build that knowledge that it's calling back on. And then Yash showed up and said, you can't just say it's doing text summarization and Q&A and just chat. I'm going to make it chat, but I'm going to make it do more for me. And so Yash has set the bar high. I hope that has helped us to, think about our extend our imagination, because somebody was saying it gives us ideas and it helps us imagine more than what we are thinking. That is precisely the power of language AI, not just to have a conversation. It's great to have a conversation, but what are you going to achieve in that conversation? How much are you going to trust it? What are you going to make it do is where we would go. So I want to show this, my screen one more time to show the deck again, because I had gotten to a place. I want to pause here and then we need to wrap up. So I was saying, one of the things, the tricks to train ChatGPT is just where I paused it, and then Yash came in and showed us a trick with ChatGPT to build a recommender system. So one of the things, now we are coming to a place where we have control. It is not just what is in the training. I was teaching you what is in the training. Now we are going to take the training and we want to build a chatbot like the AI assistant that Zoom is doing summarization for us. So what ChatGPT, what they did is, it feels like it is perfect. It is saying exactly the right thing. It is talking to us. They have done two different things. And if you are in the field of UX design, or you are a product manager, if you are working with building the chatbot in your companies, I heard that McKinsey has built a chatbot called Lily, which does knowledge management with a bunch of thousands and thousands of documents. Walmart has an AI assistant for its agents inside the company. The Zoom example I keep quoting because we are using that here. There's a lot of different chatbots, and ChatGPT is the mother of them all, because we got excited about this whole possibility because of ChatGPT, right? But how do they build it? What do? They do something called instruction tuning. So before they build out the chatbot, they actually give it some instructions, and then they see, okay, this is not right, and this is not, if is it behaving the way it want. If you see, ChatGPT is very polite. It will not appear biased, though it is built on biased training data. It will try and not take an opinion on things, and that is by instruction tuning what they've done. The other aspect, this is a huge evolving field. It's called reinforcement learning with human feedback. So what this is a part of how UX designers would get involved in building a chatbot to reinforce the learning and training the model. So it will come with an answer to a prompt, and you make it do it 3 times, and then you give it some rating and make it go back and retrain it and learn which is the better path you want it to go. And that is the reinforcement learning. So with that, I want to stop our session here today. I want to go back to what I promised as the different newsletters. My general newsletter is Jamthe newsletter, where I do a Sudha live stream, and all that links that I share. It's more opportunities and market analysis and the stuff in the AI world. If you're specifically looking to learn about LLM and generative AI, forget the book. I'm just showing that because it's my book site. But in there, if you sign up, I'll get you more learning resources related to generative AI. This is the one I was telling you that where I will be updating. Prompt engineering webinar is the newsletter sign up, where you will get the newsletter from Pariya each week. Pariya Sarin is part of our weeklywed team who sends out our newsletters. And for today's registration, what you did, I hope you came from weeklywed registration. So this is all the different options by which you can sign up. And I want feedback from you once you get the summarization of this from Zoom. So all of you have signed up on Zoom are going to get that summarization, and hopefully that will help you figure out what you understood, what you thought that there were gray areas. Give me feedback if you want me to do more demos, because this was very hard part of going into the brain of training without showing you training data, without trying to get to an intimidation factor. So I hope that helped, but I want feedback. And then I want to see if there is enough interest. I would like to come back next week Thank you, Karina. I'm glad you like this. So I like to come back and do a part 2 of this. Now we learned what is in the brain of the LLM. How does it work? What is the transform model? What is words? What are tokens, embeddings, right? And I want to take it to sequence, and then I want to show you different methods. So we don't go from here when we have the chat. ChatGPT is already an application, right? Yash showed us building on top of an application. So there's the LLM. Then there is an application you can build. And then on top of that, she was prompting to make it do more, right? That's the world we are going towards. So if you, there are options from Microsoft Azure and other places where you can actually build on top of ChatGPT, right? By prompting, and you can automate the prompt, you can make it do things. So that's one example what Yash was showing. The other thing is you could do fine tuning with an existing LLM if you're an enterprise, or you could be taking an existing LLM and doing a machine translation for a whole new language. I'm working on a project, aspirational project, to make machine translation for Bari language from South Sudan, because it's not available from any of the big technology companies. And so there could be various possibilities, machine translation. So that's the application. To get to that application, we need to understand the next step. Okay, we understood how the training was done, what's in the brain of the LLM, how does it work. Now, what are the different methods by which you can make this LLM take an input and produce an output is very high level, right? But is it going to do sentiment analysis? Is it going to take a sequence of product reviews and it's going to give me a label and say is it positive or negative? Is it going to take a chart, text, and give me the next check? That's called sequence to sequence. So that different types of sequence domains is the next step to understand what you're going to build out of an LLM. And if you're a product manager, if you're a business person, if you're sitting in a company and saying this is all possible, let's not go straight to ChatGPT. You could build on ChatGPT, but it comes with its risk, and you cannot expose your corporate data in there. So then what are your options? How do you so the understanding of that, the next level of different types of domains possible with LLM, different kind of sequencing that's possible with LLM, and then build up the different applications, then do fine tuning, or then do the prompt tuning that I was telling you about, removing bias. So those are the things that I think would be the next step of this webinar. So I would love to do another version, but I want you to tell me if this is good. Do you want it more hands-on? How do you want to do this? Because I was expecting it to be a little bit more interactive. I loved the comments on the chat, but I still think I have not got the vibe on, is this how helpful? I see the feedback. One question I did not answer, how can I add a content for prompt running? Oh, using Google Colab. So Tiago will try and give you resources for that, but we can even do a session on that separately. But thank you for asking that. Okay, so the feedback, at least from the people in the chat, are saying excellent demo and presentation. Wonderful, Yash. Thank you so much. We can definitely cover fine-tuning, Tiago. We'll do that. Especially fine-tuning. Before we get to fine-tuning, we need to understand how does the model, you have to understand, before you get to the application level, what is the kind of sequencing you're doing. And 3 different kind of sequencings are possible. So it's not just going to start chatting directly from when you give a model. It's not going to just do Q&A. It's not just going to do text summarization. Each of our different paths of taking your LLM to go build an application. What is involved in that? I think we need to understand that as the next level. Then we build the application, and then the whole decision on, hey, are we going to use ChatGPT and build on top of it? Are we going to use open source platform? Yes, showed OpenAI. What is the cost of doing that? What is the trustworthiness of doing that? What is the latency of doing that? So there's a lot of other business considerations that will come in. So with that, I'm going to wrap up. Let me see, there's one more question. Okay. So Yash was just replying back about using Google Colab, that prompt templates like today's code. You can use that. This is in response to how do you do the prompt tuning using Google Colab. That's like way advanced from where we are, but you could have a template using LangChain was our answer. Okay, so I have not done justice to everybody who is on the LinkedIn because I did not see immediate response of questions coming in, but I'm going to go back there, look at your questions and answer. If you're going to come back and watch this recording, tag friends who will benefit from this. on LinkedIn, and I will make sure that we come and answer your questions. And I want feedback. This is the part 2 of this useful and understanding the different ways by which you can now take an existing LLM, understand the different kind of sequence so that you can build. What do you need to get to building the applications, different types of application, understanding of that, and then the fine tuning and the prompt tuning and all those other goodies that you can do. So with that, I'm ready to wrap up. Thank you for staying extra time with me. I appreciate that. Thank you, everybody. I'm going to stop the recording, and we'll make this available as a webinar similar to the prompt engineering one here on Business School of AI at weeklywed. Okay. With that, let me stop the stream. Thank you, everybody. Stay safe.